Welcome everyone to Linear Equations Unit video number, well, I don't even know what it's called. It's Linear Equations video. This is a really big topic. Linear equations are a huge concept. There's lots to it. So don't think that we're learning everything in one day. Just getting started here. Let's start with this first equation here. 3 equals 2x plus 1. And please write in that little text box that this only has one variable. We have solved equations with only one variable. In this case, the variable is x. We have only solved equations with one variable for a long time, for a couple months now. And we could do this, and you could do it on your own, but you got to trust me when I'm telling you that x equals 1. This is really important to understand that this equation here has one answer, has one solution. X is 1. X is 1, and that's it. It can't be any other number. We're going to now explore down here. We are now exploring equations that have how many? 2 variables, and that would be x and y. On the left and on the right, you see the little x and the little y. Okay, so keep that in mind. We're not going to have just one answer anymore. We're not going to just have one, what we're going to call solution anymore. You're going to have more than one. Let's start by looking at the example y equals 2x plus 1. This is a linear equation with 2 variables. An equation with 2 variables. First thing we're going to need to do is make a table. This is how typically most math classes start, and we're going to start the same way. But you might remember a couple things that we did yesterday. You might remember that x is called the domain, and that y is called the range. The work is how we're going to get this x comma y together, which is an ordered pair, but more formally it's called a solution. Okay, keep that in mind, please. X is our domain, y is the range, and x comma y together is, yes, an ordered pair, but it's a solution. The cool thing about linear equations with 2 variables is you can let x or y, you can let one of those variables be whatever you want it to be. And typically we like to start with x being 0. Let's go ahead and substitute. When x is 0, y equals, I don't know. Here's what it would look like, though, when we try to figure this out. Y would be 2 times 0, which is 0. 0 plus 1 is 1. Take the x and the y, put them together, and you have our first solution. You have a pair of numbers, x and y, that satisfy the equation. We're going to talk about that a little bit more below. Don't worry about that so much right now, but hopefully the x and the y together work for you. 0, 1. 0, 1. That is our ordered pair right here. 0, 1 right here. Here's the visual. Remember, we can let x be whatever we want it to be. Last time, the first time, we let x be 1. This time we're going to we let x equal 0. This time we're going to let x equal 1. And we're going to show our work. Y equals 2 times 1 plus 1. What is 2 times 1? That's 2. Plus 1, that is 3. What is our ordered pair or solution? That is 1, 3. Plot that point to the right one, up 1, 2, 3. Boom, got another one. Go ahead and take a second to pause and try 2 and 3 and 4, and you can check what I got you should pause, and I'm just going to go ahead and start doing these. Please pause, check your answers here. Okay, we substitute. 2 times 2 is 4. 4 plus 1 is 5. Our ordered pair is 2, 5. 2, 1, 2, 3, 4, 5. Y equals, 2 times 3 plus 1. That is 7. You might be picking up on a pattern as you're checking your answers. The last one is y equals, forgot the plot. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. 2, 4. 2 times 4. 9. 4, 9. Which goes off the graph, but we can imagine it being right there. Do you notice something about those dots, about those points, about those solutions? Each of these 1, 2, 3, 4, 5 solutions, they're in a straight line. They are in a straight line, and that's not any mistake. That's why we call them linear, like a line, equations. Okay. is 7 comma 15 a solution to y equals 2x plus 1? Well, that's the linear equation we have right here, circled in red. And I don't have that in my table. I'm sure I could plug it in my table, plug x in my table, and see if the y comes out. But instead, we're gonna do something else here. We're gonna check if it's a solution by doing this. We're gonna write down the equation. We're gonna write down y equals 2x plus 1. Then we're gonna substitute. X is the 7, 2 times that plus 1, and y is 15. In an ordered pair, you got x comma y. Let's see if it works out. Let's go to green. 15. Does that equal 2 times 7 is 14 plus 1? Well, yeah. 15 equals 15. Sweet. So we know that's a point on our line. If we extended our line, it would be up there somewhere around here. That would work out. Let's check if 1/2 comma 2 is a solution. Well, let's visually check this first. 1/2, that's like here, up 1, up 2. Well, it looks like it's a solution, but we don't know until we really do the algebra. So let's do the same thing we did before. Y equals 2x plus 1. Rewrite the equation. X is 1/2, y is 2. Substitute the numbers we know. Does 2 equal 2 times 1/2 plus 1? 2 equals 2 times 1/2 is 1 plus 1. Yeah, 2 equals 2. Another solution. And again, it looks like it's a solution, but we just want to make sure that it is. You might be curious to know what happens when it doesn't work. What happens when it doesn't work? Let's look at this 15 comma 7 here. 1, 2, 3, 4, 5, 6, 7, 8, 15 comma 7. That's something around here. That's not going to work. Visually, we can see that's not going to work, but let's check that algebraically. What are we going to do? What do you think we're going to take a second pause and see if you can do it? If you said, I'm going to write my equation, I'm going to substitute x and y. This would be careful because y is 7 this time. 2 times 15 plus 1. 7 equals 30 plus 1. Yeah, no. 7 does not equal 31. So that does not work. No, it's not a solution, meaning no, it's not a point on a line. If it is a solution, you're saying yes, it's a point on the line. If it's not a solution, you're saying no, it's not a point on the line. Last but not least, how many points are on a line? Well, you might be like, well, there's 1, there's 2, there's 3, there's 4, But with every 2 points you have, between every 2 points, you can put another dot. And between those 2 points, you can put another dot. And between those 2 points, you can put another dot. Until they start overlapping. I guess my point is there are an infinite number of points on a line. There are an infinite number of points on any line. So don't say a lot. Don't say a couple, a number of points. All right, good job. Keep going. You should be almost done.